Hello everyone. In the last video, we spoke about the beginnings of inquiry-based geometry, and we had got to the point where we considered 2 points A and B, and we considered 5 different ways that we could talk about going from A to B. And we ended the lesson with the question, of these 5 ways, which one of these would be the shortest distance between A and B? Now, something that we can do actually to keep track of these is to give them a little label. And often edges in mathematics are labeled with a lowercase letter. So I'm just going to call that A. I'm going to call that root B. I'll call this C, D, and E. So of these 5, there's A going like that. There is B, C, D, and E. Now, we spoke about in the previous lesson this idea that if we're thinking about going from A to B, we can think about the roots being divided up into curved lines and straight lines. And that's a useful distinction to make. Now, if you look at these points, I think there's a couple of different ways that we could look at it, but most people after a certain period of time will go towards this idea that C would be the shortest. And the question is, why is that? And what I'm going to do is I'm actually going to dub in a conversation I had with one of my nieces about why she thought C was the shortest distance. So I'm just going to pause the video for a second and allow some time for that.
So I measured the straight line.
Yes.
And it took from 0 to 12 centimeters to get to B.
Yes.
But for the curved one, I couldn't measure it.
Yes.
But I thought how it went up, but you still need to get this bit
Yes.
up and around.
Yes.
You need more to go up.
Yes.
Than just go straight.
Aha. So it was interesting to hear that description, and I think it was a pretty good one in the sense that you know straight away that you can measure from A to B with a ruler on whatever distance it may be. But any of the other routes, not only do they have to go across the same distance, but they also have to go an extra distance, say down and up. Or if you were the curved ones, you have to go across, but then you also have to go up. And so essentially what this does, this one you can see how it goes up a lot and then it only goes across a little bit. But the main idea that my niece saw was that basically all of them are going to have to go the distance from A to B almost sort of horizontally or diagonally. And then in addition to that, they're going to have to go up and or down, which adds extra distance. And so intuitively, this idea of what we would call a straight line is really just the shortest distance between 2 points. And I think often in geometry, that is lost. And it's a very simple idea, but it actually gets used again and again throughout geometry. And so, I'm just going to leave it at that point and say, look, if we want to think about a straight line is simply the shortest distance between 2 points. Now, obviously, when we want to draw straight lines in practice, drawing them freehand is not going to be the best way to do it. So we use a tool. And normally the tool we would use would be something like a straight edge or a ruler. Now, if we want to draw curved lines, it's a little bit more difficult, and you get different types of instruments. But one of the main instruments I'm going to introduce you to is something called a compass. And so I will show you how a compass works. And basically, a compass gives us a way to generate curved lines, and a ruler or straight edge gives us a way to generate straight lines. And what we know moving forward is that a straight line is the shortest distance between 2 points. And so all I'm going to do is I'm going to play with those 2 basic ideas, and we're going to create some visuals, and we're just going to explore what that means and what we can deduce from those 2 basic ideas. Okay, I'll see you in the next video.